All right, so it's 2:45. We can go ahead and get going. Are we ready in the back? Technical? All right. All right, guys, this is Modern JavaScript for Java developers. My name is Jeremy Davis. I'm a solutions architect with Red Hat. If you're not looking for the Modern JavaScript for Java developers, now would be the time to figure out what session you want to be in, because this might be a boring topic if you're not interested in this. All right, so I want to ask, I'm probably guessing that everybody in here has done at least a little bit of JavaScript, right? So show of hands, everybody's coded at least a little bit, right? Has anybody coded lots of JavaScript? Okay, good, because then you're also in the right place. So who likes JavaScript? So kind of half and half, right? All right, so I got my first job because of JavaScript. And not, well, my first like real job, right? Not the convenience store job. But so during the .com days, I go in for this job interview, and they say, this guy's going to, I don't remember the guy's name. They say, this guy's going to interview you. And he's sitting down working, and he's like really frustrated, and he stands up and he says, I can't figure this out, and he walks off, right? So I sit down, and I get his code working, he comes back, I give him this code review, show him how it was working. He said, okay, you're good. So that's how I got my first job. But back in the .com days, right, browsers didn't work with each other, right? And we would have two huge, enormous JavaScript files, and you do browser checks to see, is this Netscape or is this IE, and you do all this other nonsense, And so I learned to hate JavaScript. And in fact, I loathed it and decided, I'm doing everything server side, right? And then I went running into to enterprise Java, right? Which was very hot at the time too, right? So it was a good thing. Now JavaScript is a lot easier to use, and it's a lot nicer. And it's not just on the client side, right? So we'll start off. I've got a lot of material also, so there's a lot of stuff. I'm going to try to get through all my slides and stuff in about 50 minutes, so we have time for Q&A. And we'll be going pretty quickly, but feel free to raise your hand or just shout out questions, and interrupt. So absolutely, you can make this interactive. All right, so JavaScript began life as LiveScript, right, in 1995, and it got renamed to JavaScript because Java had just come out, right, and Java had a huge push behind it. In fact, when we talk about Node a little bit later, I kind of see similarities, because Java really took off, right, really quickly, right? The notion of memory management was really appealing, and Node has kind of taken off, I think, in a very similar way. So JavaScript's designed to run in a host environment, right? It's not supposed to be compiled and run on a machine. It's usually run in a browser. It is object-oriented, right? It's dynamically typed, so it's very different from Java. And it also has functional elements, and you can do functional programming in JavaScript. I would say, did you guys catch Venkat Subramaniam's keynote yesterday on functional programming? I think functional programming makes a lot more sense to me after catching that keynote than it did before the keynote. So I'm not the best resource for functional JavaScript, at least not yet. Now I'm going to take another stab at it, right? All right, so why talk about JavaScript, or why use JavaScript? Well, one, it's everywhere, right? So nowadays it's client side and server side. But when I ask, who's used JavaScript, we've all used JavaScript, right? If you've done anything on the web, you've had to at least do a little bit of scripting, right? So everybody's touched this. If your background is Java, if it's Ruby, if it's .NET, everybody's touched JavaScript. So this is something that everybody has been around. It's open source, right? We have a standards body. In fact, the new standard got approved yesterday afternoon. So ECMA script 6 is now a standard. And nowadays it runs client and server. So we've got the same language, server side and client side. And pardon me while I pause for some water here. All right, some basics. So I think it's useful for modern JavaScript development. You need to know, obviously, you kind of need to know HTML and CSS, right? You really need to be familiar with Git and GitHub. All of the source code that we're talking about today is available on GitHub. And a lot of people have their sites on GitHub. So using Git, you're going to be cloning these projects. Working with a command line interface is also very helpful, right? So it doesn't have to be Bash, but a CLI is very typical. Most of these tools are going to run on the CLI, so being comfortable in that environment is a big thing. Knowing Node and NPM are also pretty important. Even if you're not doing Node programming, NPM is really important, and we'll talk about that in more depth, but it's Node Package Manager, and you'll notice pretty much everything in modern JavaScript revolves around NPM. Twitter Bootstrap is also something that's really useful. Have anybody used Twitter Bootstrap? Okay, so a lot of people use that. That's good. So it's basically a site template that you can just grab and use. And it's useful. It's used by a lot of projects. It's also a very useful thing to have around. All right, so the basics. JavaScript is object-oriented, right? And it doesn't have classes in the Java sense of classes, so objects are basically just kind of big bags of stuff, right? More similar to a hash map, where a string would be the key, and then you'd have a value for that hash map. And it does prototypical inheritance, which we have on the next slide here. Functions are also objects, and functions are first-class citizens, right? So we can pass functions around. And it's dynamically typed, right? Meaning, so you don't have to assign, my var string, right? You don't have to call anything a string. So the way inheritance works is objects have prototypes, and they have a link to their prototype. So if you query something on an object, it's going to look first on itself, and then it's going to go back to its prototype. And it will continue working backwards until it gets back to null, right? And that's sort of the end spot. Scope is also a big change from Java, right? So scope is very different than it is in Java. To give you an example, if we look at this code here, anybody have a guess of what's going to happen when we alert myvar? We're going to define a myvar up here at 0, right? And then inside of a method, we set it to 100. All right. So let's go over here to, let's open up a little tool here. This is a blue screen of death. Why is that happening? Let's see if we can drag this. There we go. All right. Probably can't see that, can we? All right, we're going to not worry about the example now because we're probably not going to be able to see this. Nah. Let's open it. So Scratchpad is a tool. Has anybody used Scratchpad before? All right, very good. Over here. Let's open our file. And run our file. It's running in this instance of the browser. And we get 100. Which is not what you would expect, right? Sorry? 50-50 chance, right? All right, so functions. Functions are all first-class citizens, right? So functions, all functions are instances of the function object. And you can assign, variables can be a function. So in this case, we have a variable named myFunction, and we assign it to a function, right? So then we can call that variable and use these methods on that variable. One thing that then allows us to do is have closures, right? So closures are sort of private functions. We can pass functions as argument to other functions, right? And this gives us private variables, so these are basically nested within one another, right? Have you guys used closures and seen closures inside of your code? Right? Okay. So another thing, modules. We have lambdas in Java now, right? So that's kind of similar, right? But closures have been around in JavaScript for a long time. All right, so modules. Modules are kind of like Java packages. And the way you declare a module is you declare a module inside of your JavaScript, and then you can then import it into other JavaScript files, right? One thing it can also do is it kind of creates singleton functionality, right? Because you can pull the same module into different spaces, and it'll still be aware of its own objects. So it's a way you can also kind of mock singletons if you're used to using that pattern, right? And we've all used that pattern a lot. Right, so the summary of this, right? JavaScript, it's object-oriented, right? But not object-oriented the way that Java is object-oriented. Functions are first-class citizens, a big difference, right? Scope is really different, and it runs in browsers. Now, if you don't like JavaScript, you can write other languages and compile it to JavaScript. Has anybody ever used CoffeeScript or TypeScript or seen, Dart or Flow is new? Facebook just open sourced this thing called Flow. So the way this stuff works is a lot of people don't like JavaScript syntax, right? A lot of people think it's kind of clunky. And so they came up with the idea, a couple of different things, sometimes to make it a little more clear or more concise, and then sometimes to add like static typing on top of that, right? And so you can, you'll throw errors if you assign, if you pass in a number where you're expecting a string. And that's the idea behind CoffeeScript, right? So CoffeeScript compiles to JavaScript. But it was an idea, this is the quote from their project, right? They wanted to expose the good parts, right, in a simple way, make it simpler. And they say, and they've got some, they've got tests, like I guess, that back this up, that it's fast or faster. So it compiles really nice, clean JavaScript when you write it. And the way it works is kind of see like left to right over here. So sometimes it's almost exactly the same, and sometimes it's not. I don't see a whole, I don't really mind curly, braces. But CoffeeScript is pretty popular, so a lot of people like using this. TypeScript is another one. TypeScript, and you notice here both of these, the way you get these, you can install these using NPM. And we'll talk about NPM in greater detail. This is just kind of one thing to see is all this stuff is available through Node Package Manager. So TypeScript adds a lot of things that you're going to be used to from Java, right? So you're going to have classes, you have modules. The classes are in version 6. Like I mentioned, it got approved yesterday. But they're not really true classes. It's really just kind of syntactical sugar to make it look like classes if you want to write that way. And then TypeScript also compiles to JavaScript. It looks a little bit different. So you have like, class. And this is definitely going to be more familiar if you're coming from a Java background. Dart is a language that Google created, right? You don't install it by saying npm install TypeScript, but that's an error. But it's similar to syntax is a little bit different, but again, it's going to look more like Java, right? It's going to look more statically typed, but it compiles down to JavaScript. Right, so to sum this up, if you don't like the syntax of JavaScript, you don't have to use the syntax of JavaScript. You can use higher level languages that then compile down to JavaScript and will run as JavaScript. One thing though is you shouldn't really skimp there, so I wouldn't recommend starting because you're starting at a layer of abstraction, right? Has anybody ever used GWT? Like GWT, where you use Java to compile down to HTML and JavaScript? So I did a project with that. It's kind of the same thing. When you're working with a higher level language to compile down to something else, eventually you will run into some strange kind of bugs, right? You can spend some tough time debugging that. All right, so that's kind of the end of the basics here. Let's talk about how we actually write or how we're going to work day to day, right? When the Java world, the way we build things, right, typically you're going to be using one of these 3 tools. You're probably using Maven, right? Everybody Maven guys, right? Anybody use Gradle? Yeah, Gradle's really cool, isn't it? I like Maven for bigger projects, but Gradle's really nice. So you're probably going to use one of those. There's not really a one-to-one match. Like we can kind of just use Maven for everything. That doesn't really exist in the JavaScript world. There's a number of different tools. NPM we've kind of already seen, right? So NPM handles installing lots of things. So if you think about the way that Maven's going to go out and search repositories to grab jar files for you, NPM is going to have that kind of role a lot. And these things are sort of, they interact with one another. So NPM is package manager for Node.js. It's been around for about 4 years. When you say NPM install, and then you can give it, there's various flags you can give it so you can install it, globally. But it's going to go out, it's going to search, it's going to find these packages, and it's going to pull them in. There's also the availability, there's a company around this as well, so you can have private Node packages, kind of similar to the way, you can use various Maven tools, right? Grunt is a task runner, so it does a bunch of different stuff, and it has a plug-in ecosystem, and it handles repetitive tasks, like things that you're going to do a lot when you're coding, whether that's running tests, whether it's starting a local server so you can preview your code, whether it's minifying your code. Are you guys familiar with the term minification? Minification? Okay. So Grunt can handle all this sort of stuff, has lots and lots of plugins, and then it's wrapped by a lot of other tools, too. So even like Yeoman, which we'll jump in and take a look at Yeoman in a second here. Yeoman's going to call down to Grunt for a lot of what it does. Grunt runs off of a JavaScript file. So when you look at this, you're going You have a configuration. You can look through here, right? And it's going to watch. It's calling Bower, the other tool in here. But you just code up JavaScript for Grunt. And a lot of this is automated too. One thing that's really nice about the JavaScript world is these guys really, the people that write these tools really take to heart auto-generating stuff. So you can scaffold out a lot of this stuff. Bower also finds and installs stuff, but it's all web level stuff, right? So it's not competing with NPM. NPM is going to go get Node packages, which are going to be JavaScript packages to run on Node. Bower is going to go get all your stuff like jQuery, right? So it's going to go find all your stuff, and it's going to stick it in a folder called Bower_components. And if that inside of it's also going to create a dependencies file, which this is going to look very similar if you guys have ever used Ruby, right? And you use YAML as a JSON, right? But it's telling us and this would be for an Ember application, right? And it's telling us what it needs and the version it needs. Where it's going to do that, if we look like in an application here. We'll have a Bower components folder, and everything will just go right in there. So jQuery in there, Angular resources. It'll stuff everything in there for us. All right, so Yeoman. Yeoman is also installed using NPM, and it's a scaffolding tool, right? And it runs on the concept of generators, and you have generators for lots and lots of different stuff. And it leverages Grunt and Bower as well. So those are going to be used under the covers by Yeoman. This application that we're looking at right here, so this was generated by Yeoman. And it can build out your whole app for you. And even whoops. Sets up an application that's ready to run and sets up test runners. It's going to watch your code. It'll automatically run tests, and we can kick off a server. But basically, you can scaffold up an entire application ready to go. So if you're used to using things like Ruby on Rails, where you're used to having everything ready for you, Yeoman is going to be a very similar kind of tool. It also makes it very easy. Because there's generators for a lot of different things, it makes it easy to get started and get up and running. So if you want an Angular app, you can generate an Angular app. If you want to then, say, try out an Ember.js app, you can then scaffold out Ember. And if you want to do Backbone, I think there's a Backbone one as well. So you can try various different frameworks. So to sum this up, there's multiple tools, right? Like in the Java world, we pretty much work just with Maven. We don't have one analogous, one-to-one mapping with that. We have a lot of different tools we use, but these can all be wrapped by other tools, right? So Yeoman can wrap these. All right, so when we get into actual development, first things first from development, like test-driven development, right? So you guys do TDD? Anybody do behavior-driven development? Behavior-driven? Behavior-driven development is a little more common inside the JavaScript space. I personally don't like that syntax. I don't really know why. Maybe just because I just wrote JUnit tests for so much of my life that I like that kind of syntax better. But BDD seems to be a little more common. But there's lots and lots of different testing frameworks. These are kind of the biggest ones. Jasmine is really probably the biggest. QUnit has been around a long time. It's XUnit style testing, right? It can test any kind of JavaScript. It's used extensively by jQuery. This is what the syntax looks like, right? So you write a function, and we have then and expected, right? And you just call the test method down here, and you pass in variables. You can wire this up pretty easily. Like I said, I always liked writing JUnit, and so this syntax is very comfortable for me. Jasmine is really widely used and seems to be the choice for most of the JavaScript world. It's behavior-driven, so BDD. So you describe something, and you say, it. It also has matchers. There's lots of different matchers. And you guys know what I mean by a matcher. We'll just go over here. So what I mean by a matcher is the piece where we say expect to be. That to be is the matcher, right? And you have like to be, to match, to have, and you can write your own matchers, right? So there's APIs for this. There's plenty of those things out there as well. But this is BDD, right? So we describe a suite, and then we say it contains a spec with an expectation, right? And then we expect true to be true. Anybody use like Cucumber and stuff inside of? Okay. All right, Karma is one of the coolest things. It's one of the coolest testing things. What this does is it fires up a browser, it watches your source code for changes, and then when it finds changes, it kicks off your test suite for you, right? So it makes test-driven development extremely easy, right? So let's run that. We can run this here. Let's change a test. Let's change something in here. So I just save that file, right? It changes, it detects the change, runs my test cases pass, right? So you can have this running while you're testing, right? So you know immediately if you're going to break anything, right? So it's a really, really quick feedback loop. Right now, remember, JavaScript runs in browsers, right? It's written for browsers. So things like JS Fiddle, you can test right inside of a browser, right? So you can come in here if you want to try out scripts. Where's my other JavaScript? So with JS Fiddle, we can just copy code right in here. Click run, and run our code. You can also type HTML and CSS in here as well. Right, so ultimately, it's really easy to do TDD or BDD in the JavaScript space, right? You set your application up. You can watch your application while you're developing. You can watch your test. You can automatically run the test. So there's basically no excuse not to do that. Another nice thing is because it's a dynamic language, right, and it's not compiled. If you're not testing early on, it becomes harder to wrap that in, right? Because Java, the compiler is kind of our first line of defense, right? When we pop something open inside of Eclipse, we can kind of see little red squiggly lines, so we know, right? If we break stuff inside of JavaScript, it's not going to be that easy to find, right? Same with any kind of dynamic language. All right, so frameworks. There's lots and lots of JavaScript frameworks out there. I think we're kind of like right now, we're sort of in a space where if you go back before Spring MVC kind of became the de facto for the web, right? You remember there's lots and lots of different Java frameworks. There's kind of a new one every couple of weeks. We're sort of right there. I'm going to talk about 4 of these because they kind of just illustrate just a few different approaches. And then AngularJS is probably gaining the widest market share or mind share today. Has anybody ever played with any? Everybody's probably touched jQuery before. Play with Ember, Angular, Backbone. So, good. All right, so jQuery's been around forever, right? It's 10 years old. It's completely mature. It's everywhere. Integrates with JSF, right? I mean, so pretty much everybody's seen this. Syntax is pretty easy, but it's also it's an abstraction above immediate DOM manipulation, right? But it's not too much of an abstraction, right? We're certainly not at the layer that we'll see like with Angular. All right, so Backbone, what Backbone does, this is very minimalist. It has a lot of traction though, among some pretty big websites. It's not very heavyweight. It's a model view presenter framework, so a little bit different from a model view controller. It's Templating is pluggable, so templates are how you're going to generate your front end, and it's pluggable, so you can use different ones, although you usually use Express.js, so there's usually one that you use with that. _JS, sorry, not. All right, so Ember is a different approach, right? Ember is very much a big, opinionated, heavyweight framework. It has a great logo, right? I love that logo. But it's a big, heavyweight, opinionated framework, meaning it's going to want you to do things a certain way. And the guys that wrote this wrote the Apple web stuff, so the Apple, the online mail and the Apple clients. It's the team that wrote that. And it favors convention over configuration. And it's really heavily based on routes. The concept of routes is really key to the way that Ember works. It has a big learning curve. Anything other than like Hello World, it has a big learning curve, and it very much wants you to do things its way. There's pluses and minuses to that, right? I mean, on the one hand, if you have a big team of people or if you have a lot of churn in your team, then that may not be such a bad thing, right? Because everything's going to be where you expect it to be. I mentioned that routes is kind of what a route looks like, right? But the notion of routes, and they all have like, what do you call it, bangs inside of the URL. But everything is based on the notion of the URL because the web itself is based on the notion of the URL, right? There's not a lot of mind share around Ember. People who use it love it, but it doesn't have it's not really as pervasive as Angular, right? So everybody has heard of Angular probably, right? Anybody using Angular at work? It's okay, so a number of people are using Angular. Right. I've definitely heard a lot more among at least my customer base of people looking at Angular, and I know it has a huge amount of mind share, right? So, the things that Angular brings, right? So their phrase, I love their phrase, like what HTML would have been had it been designed for applications. And kind of the two big things it does, one, it does dependency injection, which is hardly new to us in the Java space, right? We all know what dependency injection is. That was pretty new in the JavaScript space, though, right? So that was a big innovation on Angular's part. And then it does what they call two-way data binding, right? So you bind the view to the model, and when that model changes, when your data changes, the view changes as well, right? So it changes dynamically. The way it does that is when you look inside of an HTML page, you can see these, a pointer here, you can see like these curly brackets where it's going to put out part of a model. And then it wraps basic HTML tags, right? So the way it does that, if we take a look at something that's pretty similar, pretty basic HTML, right? This is an unordered list. Well, instead of our list item, we have this ng repeat thing here, right? And we have an ng source on image. So what Angular does is it extends HTML. And when your page loads, it evaluates this. So it's going to look for phone images. So it's going to look for a property on a phone object, right? And it's going to iterate through there. And it's going to print out that image. Whoops. And it's going to print out that image. Everybody clear on what this is doing? So what this is doing is it's wrapping your basic HTML. And this is a pretty much paradigmatic shift in the way that people treated doing generating dynamic stuff on the web, right? So there's templates have been around for a long time, and templates are pretty similar in a lot of different languages. JavaScript's kind of the same. But this is really different, right? Because it's really going at the heart of HTML and extending that to make it HTML for applications. Now, Angular is for single-page applications, right? Everybody familiar with the term single-page applications, right? Where you're basically going to rewrite part of the page, but you're not going to rewrite the whole thing. Single-page applications aren't for everything, all right? So, and they kind of specifically say, like, here's, these are some good use cases. These aren't good use cases. Let's take a look at. Angular has, this is our function, right? So we have an application here. It has a notion of, it has controllers and it has services. I'll pull up here is our main.html. Where's my browser? Sorry, lots of windows open. And so here's an Angular application that I generated using Yeoman. This is an example app, and that's what's running down here. Another really nice piece of functionality here, my to-dos for DevNation. We can save that, and just on the save, because it's watching that file, it automatically reloads this running browser. So you don't have to even refresh your browser, which is also, again, a really nice, tight feedback loop. And sorry, I got to pull this over here to find my page. So the way that Angular does routing, can you guys read this? We can get that bigger, Control+. So this is a main page, and we just have ngView right in here, right? So this is we have a class view container, and we just have a view. Inside of here, we will populate various different partials depending upon what somebody clicks on, right? So it's going to rewrite what's inside of that piece of the DOM based on where you click, based on the URL that you're on. It also preserves your URL, so you can, you don't have a problem going with back buttons. You don't get lost. We do it all the time. All right, so templates. So there's lots of different templates. Mustache is a really old one. Handlebars is an extension on top of Mustache. There's Dust. Jade is very different white space matters inside of Jade. Let me show you an example of what these look like. They all look more or less kind of the same, right? And if you've used any kind of HTML language outside of Java, Java has JSPs where you script or it has tags, but if you've used any other kind of language, you're sort of used to this type of syntax. But the way they all pretty much work is you have a piece inside of here, right? So you have some sort of placeholder, usually with curly brackets, inside of your HTML where you're going to render this template. And there's a lot, yeah?
So the templating that you're talking about here would be using something like Express, right?
Ember uses handlebars.
So would there be any conflicts with something like Angular that uses the double curly bracket as well?
You wouldn't use this with Angular. Right. Yeah, different paradigm. All right, so ORM, right? So in Java, we have JPA, we have Hibernate, right? Those, they kind of won the battle. You also have ORM inside the JavaScript world, right? So Mongoose is specifically designed for MongoDB. There is Backbone ORM, Bookshelf. There's a number of different ORMs. Most of them work with Mongo. Some of them specialize on MySQL or Postgres. But you have ORM functionality. Functionality is fairly similar across them. It's what you kind of expect from ORM, right? I mean, in some of them, you can find all instances of an object from the object instance, and there's differences between them. Mongoose seems to be getting into mean stack. We'll see some Mongoose, but ORM. So it's going to be a little bit different from Java, but it's still going to be pretty much the same kind of paradigm, right? You're not going to have to go and like pull your database records out one by one and marshal them yourselves into your objects. So in that sense, that moves pretty easily from Java to JavaScript world. All right, so code quality. You guys do code analysis, run through do automated builds and do code quality analysis. You can do the same thing inside of JavaScript, right? So there's JS hint and JS lint. We were running JS hint when we were running the browser there to run in JS hint. In fact, it'll say JS, well, it failed. We're running JS hint. And what this is going to do, it's going to look through your JavaScript code to find errors. You can also run this like JS lint. You can just go to JS lint. You can type in JavaScript in here, and it'll give you hints about your code, right? Or it'll tell you the lint inside of your code, right? You can run both of these, on the command. You can wrap these in your application. Let's see. Where's my browser? Well, that's using, it's watching, so Karma's watching, and it's going to kick it off, right?
Are data
Heck.
and length trying to solve two different problems?
No, it's pretty much the same problems, just different implementations. All right, so IDEs, right? Coming from the Java world, we use IDEs a lot. So Eclipse, everybody uses Eclipse probably. IntelliJ, NetBeans. A lot of IntelliJ guys, NetBeans. What else? What else do you guys use? What else? VI. All right, there you go. You're ready for JavaScript right now. Right? Do you even use like Vim improved or just plain VI, right? All right, so in the IDE space, right? WebStorm is made by the IntelliJ guys. It's a really nice editor. Aptana is kind of older. It's a little long in the tooth now. It's based on Eclipse. Eclipse, obviously, you have HTML, CSS, JavaScript plugins. NetBeans does as well. This is Visual Studio. Just added a bunch of functionality for JavaScript. Sublime Text is also probably the most widely used one. Sublime Text is this one. And then this is Atom, and Atom was written by GitHub. So they liked Sublime Text, but they had some changes they wanted to make. One thing that's kind of nice about it is it's written in JavaScript. It renders kind of slow. My impression, do we have any Atom fans? Anybody like using Atom? So I'm not going to offend you. So my impression was like GitHub thought like we were using Sublime Text, but it just doesn't suck enough, right? And so they built Atom, right? It was my impression of having used it, right? So WebStorm is really nice. It's built by the IntelliJ guys. So if you're used to using IDEA, it's going to be very similar. It has some nice code completion functionality in there. It's a Java-based UI. Lots of plugins. This Angular phone cat, it can generate applications for you, so it wraps some of that generation. You can generate out an Angular application, and it'll call down into Yeoman to do that. Sublime Text, I really like Sublime Text a lot. I've been using it forever. It's very customizable. In fact, one thing that I really miss, because my favorite thing out of Eclipse is when you can hit enter and you just go to you go outside of your curly brackets, or you go outside of your parentheses, right? I just think that's so useful, and like no other editor has that, and I just think it's like the best function ever. So it was actually pretty easy to write the key commands to do that, right? And so you can extend, you can really hack on Sublime Text and put in the functionality you want. There's also lots of different hacks that other people have done, so you can grab those right out of GitHub and install them. This is written in Python. It's a little bit more responsive than Atom is, but they're both pretty similar. And so you don't get, and it does a little bit of code completion. It's not the same kind of thing. Like it's not going to do like what IntelliJ or Eclipse would do and build the DOM up, because it's JavaScript, right? It's dynamic, so you can't really do that. But it does do some hinting, largely based on other keywords that it finds inside of your files. So you do get a little bit of that kind of code completion stuff. But it's really nice. They request that you buy it. You don't have to. I think it's like $65. So also in development, because JavaScript is built to run in browsers, right? Your browser is going to be a tool for you, right? So there's tools in all of the main browsers. I realized I didn't put Internet Explorer on here, but I haven't used Internet Explorer like in forever. So I don't really know what it looks like anymore. And I have a Mac, and that gets me in a little bit of trouble at Red Hat, but I usually use either a Mac or Linux, right? But inside of your browsers are lots of tools. We just opened up Scratchpad. This is Firebug. Firebug's a plugin, and there are plugins for both Firefox and for Chrome. There are huge ecosystems of plugins, right? And you can just kind of you can search on these, pull in all kinds of different plugins. Ember, for instance, has a plugin built in right here just specifically to inspect Ember applications, and it can like show you, where everything is. But you can do, this is HTML, JavaScript in here. You can set breakpoints, steps. Has anybody step debugged through Firebug? Okay. So yeah, you can step debug, the way you're used to debugging stuff or the way you're used to editing. There are all kinds of other tools too. We saw Scratchpad. So I can figure out where my browser is. So here's like the Ember plugin, which is not detecting an Ember application. Although it should be detecting an Ember application running right there. And like I said, they do have my favorite logo, and even like their confused logo. They have the best logos. It's also something I've noticed there, and I think this comes from JavaScript having closer ties to the web and having closer ties to designers. Every JavaScript project in the world has like kind of a cool logo. And I don't remember that in the Java space. Like, there's not automatically a cool logo with your project, right? You start an open source project, you somehow get a cool logo. In the JavaScript world, you do. I don't know who it is that designs those for them, but you get that. Like in Firefox, we have Firefox add-ons. You come here, you find these things, you just add them right into Firefox. There's huge ecosystems for both Firefox and Chrome. So have multiple browsers on your machines. There's decent stuff in Safari too, but obviously not quite as big an ecosystem. Be sure to get these plugins and get plugins working and have multiple browsers. Other testing stuff too that you can do inside of your browser. All right, so server-side JavaScript, right? So that's how you develop client-side applications. Server-side, really, it didn't start with Node.js. It started with Rhino, right? So there was a JavaScript implementation in the JVM, so you could, right? Did anybody ever use Rhino for anything? You used Rhino? Did you do a whole project and stuff in it? Or? Yeah? Okay, very cool. All right, so I never used Rhino, right? So Node.js came out in 2009, so we're 5.5 years ago, and this is already pretty pervasive. So I think this is pretty much a landmark. I said it kind of reminded me of Java. Within the first few years Java was around, it really exploded, right? The notion of memory management really appealed to a lot of people. It was something better than C++. Well, Node is really built for the web, and it's built to be very, very fast. And a huge ecosystem has developed around Node in just 5 years. If you guys have seen any of the talks from Red Hat Mobile Application Platform, which used to be called FeedHenry, it's built on Node, and those guys have given a couple of talks this week. There are a lot of supported products that are built on top of Node. Most cloud providers now have support for Node. So OpenShift has support for Node. Microsoft Azure has support for Node. Joyent, it was built by Joyent, who's a cloud provider. So it's really taken off a lot of traction. It's built on top of the Google V8 engine, but that's released under a BSD license. So there are no concerns about Google kind of owning that code, right? Because BSD, anybody can fork it and use it for anything. But the key piece behind Node is it does it's non-blocking, and it has its own event loop, right? And the event loop is really invisible to you as a developer. Duplicate slide there. NPM also. So NPM started in 2011. The number of packages on NPM are in the tens of thousands, right? So there's already tens of thousands of plugins that are available for Node.js in just a matter of a couple of years. All right, so the mean stack. So the mean stack, has anybody heard of mean stack or used mean stack at all? Used mean stack? Mean stack. Okay. So mean stack's Mongo, Express.js, Angular, and Node, right? So it's a full stack, Node web framework, right? And this is gaining in popularity quite a bit. I mentioned you can also use ORM. So you've got JavaScript-based ORM. Mongo itself, if you guys have played with Mongo. So you see, JavaScript's kind of the query language, right? And then more server-side JavaScript. So have you guys heard of Nashorn, right? In Java 1.8? So this is the new rewritten JavaScript engine that is inside of the JDK, right? And you can run it on the command line by typing JJS out of your Java home bin. You can import it using JavaX script, and then you can use it and then you can import other JavaScript libraries. So I don't know exactly where this is going to go. A few years back, I really thought we were going to start seeing a lot of polyglot stuff on side of the running on the JVM. I don't think that's really taken off so well. But I definitely think that there is some interesting potential here. One, you can like if you're using Mustache templates, right? You can now pull those templates inside of your Java code, and so if you want to do server-side rendering, you can use the same templates that you're using inside of your client-side application. And then you can write JavaScript and import your Java files, and then execute it on the JVM. Now, Node does not run on the JVM. And I know at NodeConf, which was earlier this month, the first or second week of the month, there were some talks. There was an Oracle project to port Node to the JVM, to run on the JVM for integrations. Because I don't know if any of you guys saw the Feed Henry talks, but integration can get kind of ugly right on the back end. So there was an effort to port that to the JVM. We had our own project called Nodine that was to port it on the JVM. The Oracle guys have kind of thrown their hands up. Most of the Node packages will run on the JVM fine. There is one core package, though, that that virtually everything calls into, and nobody's been able to successfully port that over to Java. So it looks like, at least for the time being, Node is going to stay, C++, and it's going to stay compiled, for each OS. So I don't think we'll see that, but definitely this makes the Nashorn engine. Nashorn is the German word for horn, so Rhino, right? The Rhino book from JavaScript. But it's much faster. It was rewritten to use the invoke dynamic function inside of the JDK. So it's much, much faster. All right, 15 minutes left for Q&A.